In this video, you will learn the basic rules of factoring. Let's start off by factoring 4x squared plus 2x cubed. Now, in order for us to factor this, we need to first take the coefficients and find the greatest common factor. So in this case, the greatest common factor of 4 and 2 would be 2. Then we look at the variable, and we have x squared and x cubed. So we need to figure out the greatest common factor between x cubed and x squared. In order for us to do this, we simply look at the smallest exponent. So the smallest exponent is 2, so x squared would be our greatest common factor. Now that we have 2x squared, we need to take our 4x squared and our 2x cubed and divide it by 2x squared. So we need to take 4x squared divided by 2x squared. In order for us to divide this, we first divide the coefficients. So 4 divided by 2 is 2. And then x squared divided by x squared just cancels out, so we're left with 2. Then we have 2x cubed divided by 2x squared. Now the 2's cancel out, so we're left with x cubed divided by x squared. And this gives us x. So we factored this to 2x squared times 2 plus x. And we can check our answer by doing distributive property. Now let's look at a slightly complex example. 3xy plus 6x cubed y plus 9x squared y squared. Now in order for us to factor this, we basically follow the same steps. We look at the coefficients and figure out the greatest common factor. So in this case, the greatest common factor is 3. Then we look at our first variable, x, and we figure out the greatest common factor between the x, and in this case it would be x since it's the smallest exponent. Then we look at our second variable, y, and we figure out the greatest common factor, which is the lowest exponent, which in this case is simply y. Now that we've taken out 3xy, we need to fill in what's left. So we do 3xy divided by 3xy, and that gives us 1. Then we go on to our second term, 6x cubed y divided by 3xy. So we start off with the coefficient. So 6 divided by 3 is 2. And then x cubed divided by x is x squared, and y divided by y simply cancels out. So we're left with 2x squared. Then we have 9x squared y squared. So we do 9 divided by 3 first, and then we have 3, x squared divided by x, then we have x, y squared divided by y, and then we're left with y. So this is the factored version of our expression that we had before. Now let's factor this. 3x times x plus 1 plus 4 times x plus 1. Now as you can already see, x plus 1 is common between 3x times x plus 1 and 4 times x plus 1. So we can actually factor out x plus 1. And then we're left with 3x and 4. So what we do with 3x and 4 is that we combine them and we get 3x plus 4. So we factor this to x plus 1 times 3x plus 4. Now let's move on to a simple trinomial. A simple trinomial essentially has the term x squared, x, and then a number that doesn't have x or any variable attached to it. And one thing to note is that x squared doesn't have a coefficient in front of it. It's by itself. Now, in order for us to factor this, we need to look at these two numbers. So the 3 that's not attached to a variable, and the 4, the number that's attached to the x. And in order for us to factor this, we need to figure out two numbers that multiply to 3 and two numbers that add to 4. So two numbers that multiply to 3 are 1 and 3. 1 times 3 is 3. And if we added 1 and 3 together, we would get 4. So that means our numbers are 1 and 3. Now we simply take x and add it by 1, and we take x and add it by 3, and we just multiply it, as you can see. Now let's move on to another example of a simple trinomial. So like before, we are concerned with the negative 12 and the negative 4. So we need to figure out two numbers when multiplied equal negative 12 and two numbers when added equal negative 4. So let's try negative 4 and 3. Negative 4 times 3 is negative 12, but negative 4 plus 3 is negative 1. So these aren't the numbers. What about negative 2 and 6? Well, 6 times negative 2 is negative 12, but negative 4 plus 6 is positive 4. So what about negative 6 and 2? Negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. And so we have found our numbers. A good way to do this is to start off by listing out the factors of the number we're trying to get by multiplication, and then adding them to see if we get our second number. Now that we have -6 and 2, we simply take x subtracted by 6 and take x and added by 2, and then multiply them together. Now what about complex trinomials? So we have factored simple trinomials which have no coefficient in front of x squared. But as you can see here, there's a coefficient in front of x squared, which is 2. So the fastest way to factor this is by using the x method. So in order for us to do this, we take the two numbers at the end, so the number attached to the coefficient of x squared, and the number that it doesn't have a variable after it, and we multiply them together. So in this case, 3 times 2 is 6. Then we take the number in the middle, which in this case is 5, and we put it at the bottom. Now we're trying to figure out two numbers that multiply to 6 and add to 5. So in this case, those two numbers are 3 and 2. 3 times 2 is 6, 3 plus 2 is 5. Now what we do with these numbers is divide it by the coefficient in front of x squared. So in that case, it's 2. And we do 3 divided by 2 and 2 divided by 2. Now we can simplify 2 divided by 2 to 1. So what we got from this is 3 over 2 and 1. Now what we do with 3 over 2 and 1 is that when we have our two expressions, the first one, the denominator of 3 over 2, becomes the coefficient of x. And then the 3, the numerator, is being added to it. So we have 2x plus 3. Then we take the 1, which can also be written as 1 over 1. So the denominator, 1, goes in front of x, which is simply just x. And then we add it by the numerator, which is just 1. So we are left with x plus 1. So we factor this as 2x plus 3 times x plus 1. Now let's factor x squared minus 16. So whenever we have two perfect squares, so in this case we have x squared and 16, and they're being subtracted together, what we can do is that we can take these perfect squares and square root them. So when we square root x squared, we get x, and then when we square root 16, we get 4. So we can make x minus 4 times x plus 4. So what we did is that we square rooted these perfect squares and then subtracted their square roots and then added their square roots. This concludes basic factoring. If you have any questions, you can leave them in the comments below.